This is the fourth video in the stoichiometry unit. Our topic is mole-to-mole conversions. So that by the end of this video, you're going to be able to use factor label method in order to convert between moles of one compound and moles of a different compound. In order to use your time wisely and effectively while watching this video, make sure you have your periodic table, your calculator, a pencil, and your notes or capture sheet. And as always, feel free to stop the video, rewind when you're confused, or stop the video and try the example problem on your own first. So during chemical reactions, we always make a new compound. Sometimes we're going to want to calculate what this compound is in advance, or we might want to calculate how many moles of reactants are going to be used before we get started with the reaction. Think about it if you have any kind of ideas why it might be important to do this before you get started. We'll be talking about that in class. Now, what kind of information can you get from a chemical equation? Well, from a chemical equation, we can find out what our reactants are, because they are always on the left-hand side of the equation. And we can find out what our products are. But in order to be truly effective, a chemical equation shouldn't just be a chemical equation, it should be a balanced chemical equation. That's going to give us the most information possible. So in order to make this a balanced equation, we're going to want to add the two here and here, so the number of atoms of each type of element is the same on both sides. At this point, we can get not just the reactants and the products, but we can get what we call mole ratios. Now, what are mole ratios? Mole ratios just tell you how many moles of each reactant or each product you need to have during the course of the reaction. So, for example, if I had 2 moles of sodium, I could make 2 moles of sodium chloride. Now, this is a ratio, so you could also have 1 mole of sodium making 1 mole of sodium chloride. That's the same ratio. Other ratios you could have would be 2 moles of Na will react with 1 mole of Cl2, or 1 mole of Cl2 will react with 2 moles NaCl. And of course, they're just ratios. Maybe you don't have 1 mole and 2 moles. Maybe you have 2 moles of Cl2 and 4 moles of NaCl. Now, if you notice, I wrote down the ratio sign. I didn't write down an equality sign. And the reason why I didn't is because 2 moles of Na is not the same thing as 2 moles of NaCl. But even though it is a ratio and not an equality, these can still be used as conversion factors. And as a result, is going to increase the numbers and types of calculations we can perform. Let's try one. So in this case, we've been given our balanced chemical equation. We can see that above. And the question is, how many moles of the sodium chloride can we make using 1.27 moles of chlorine? Well, as always, we would like to know what our conversion factor is. And between this, we have 1 mole of chlorine to 2 moles of sodium chloride. I'm going to write that down. 1 mole of chlorine to 2 moles NaCl. Now let's get started with the calculation. We always start with a given, and our given is the 1.27 moles of chlorine. After the given, we're going to have our conversion factor, or in the future, maybe more than 1. Now at this point, we want our units to cancel. So whatever this unit is, it's got to go to the bottom of the next section so that it can cancel. So I'm going to write down moles Cl2. Now I need to know what should I put here and what should I put here. So I'm going to go up to my conversion factor and take a look. Moles of chlorine. Moles of chlorine is 1. 1 mole of chlorine. So the 1 goes on the bottom. The rest of the conversion factor, that's the 2 moles of NaCl, is going to go on the top. Now, before I pull out my calculator and do the calculation, let's see what we can cancel. As long as it's exactly the same on the top and the bottom, I can cancel it. So moles of Cl2 cancels with moles of Cl2. So when I'm done, I'm going to have moles of NaCl for an answer. Now, in my calculator, I do 1.27 times by 2 divided by 1, because you always divide the bottoms. And that gives me an answer of 2.54 moles of NaCl, which is my final answer. 1.27 moles of chlorine can make 2.54 moles of sodium chloride. Let's try another. Okay, same balanced chemical equation. How many moles of sodium and chlorine do you need to make 2.81 moles of sodium chloride? In this case, excuse me, that's a moles. I don't want to put a mole there. Don't want to change the units. In this case, I'm solving for sodium and chlorine. So I'm going to have two different factor label methods. So for each compound you want to find, it is a different factor label method. Now, after I have my given, I want to figure out my conversion factors. So I know what to put here. I'm going to use two different ones. The 2 moles of sodium to 2 moles of sodium chloride, and I'm going to use the 1 mole of chlorine to 2 moles of sodium chloride. Let's get started. Whatever this unit is, it has to go down to the bottom of the next section so that it can properly cancel. Now I need to know what to put with the moles of sodium chloride, so I look above the balanced chemical equation and it's 2 moles. And then on the top is the rest of my conversion factor. If I'm solving for Na, it's going to be moles of Na, and the coefficient is a 2. Now anything that's exactly the same on the top and the bottom are going to cancel out. So moles of NaCl cancels, and I have 2.81 times by 2 divided by 2, or 2.81 moles Na. That's the first half of my question. Now the second half of my question I'm going to solve for the chlorine. Now, as before, whatever's up here has to come down. So moles of NaCl comes down. And I want to see for this mole to mole ratio, because I'm going to go from moles of NaCl to moles of Cl2, what these coefficients should be. So I'm going to look above. It's 2 moles of NaCl, so I'm going to put a 2 there. And then for the chlorine, it's 1 mole of chlorine. Now, before you get going, you should cancel out the units that you can. Moles of NaCl, exactly the same, one on the top, one on the bottom. So it's canceled. 2.81 times by 1 divided by 2 is 1.405 moles of chlorine. So the answer to my question is, I'm going to make 2.81 moles of sodium, or I'm going to use 2.81 moles of sodium, and 1.45 moles of chlorine. Both of these are my answer. Which brings us to our third problem. A student mixes 0.835 moles of sodium and 0.521 moles of chlorine, and wants to know how much sodium chloride can they make. Well, similar to the last one, I have two givens. So I'm going to have two factor label methods. On the first one, let's do the sodium to sodium chloride. So I'm going to have 2 moles Na to 2 moles NaCl, starting with a 0.835. times by, now the moles of Na has to go on the bottom of the next section so it can cancel. And looking at my conversion factor, what number goes with moles of Na? The answer would be 2, so 2. And the rest of the conversion factor, the 2 moles of NaCl, goes on the top. I'm going to cancel out the units that I can. So moles of Na is exactly the same on the top and the bottom. That's canceled. And then 0.835 times by 2 divided by 2 gets me 0.835 moles NaCl. But I'm not done, because I also have this 0.521 moles of chlorine. So I have to do a different factor-label method. There's 2 givens, 2 factor-label methods. So 0.521 moles chlorine times by, now let's take a look at that conversion factor. It's going to be 1 to 2. So 1 mole chlorine will make 2 moles sodium chloride. Now, as before, the unit up here has to go on the bottom of the next square so it can cancel. I'm going to go take a look at my conversion factor, and in front of the moles of chlorine is 1. So the number that goes with moles of chlorine is 1. The rest of the conversion factor, 2 moles of NaCl, goes on the top. Now, before I use my calculator, I want to see what can cancel. Moles of chlorine is exactly the same unit on the top and the bottom. That cancels. So 0.521 times by 2 divided by 1 gets me 1.042 moles of sodium chloride. Now I have a big question. What do I do with these 2 numbers? Well, you need to think about, what do these 2 numbers really represent? What it's representing is, I have enough sodium to make 0.835 moles of sodium chloride. I have enough chlorine to make 1.042 moles of chlorine. But I need both of them to make sodium chloride. So what it means is the following. Since I have enough chlorine to make 1.042 moles, but only enough sodium to make 0.835 moles, and I need both of them to make NaCl, I'm only going to make the 0.835 moles of sodium chloride. In other words, sodium is going to run out before I'm done using the chlorine. This is very similar to what happens in your home. If you're trying to make sandwiches and you run out of bread, it doesn't matter how much ham you have left to make your sandwich. The same thing is true here. Do both your reactants and see which one makes less. The one that makes less is how much you actually make.